Okay guys, welcome back to part 2 in our layout. So what we're going to be doing is we're going to be laying out some of this. I'm just going to show you some quick little layout tips, and I'll even show you the auto router. So what we're going to do is we're going to do first of all a copper pour. What I mean by that is we're going to basically make the whole back side of this board copper so that we can punch through and get grounds. So let's go ahead and choose our Polygon tool. And we want the bottom layer, so we definitely want the bottom layer. So now the width of this, you can make it 1 mil because it really doesn't matter because it's going to be just a thick copper pour. So what we're going to do is, 1 mil, is we're going to come in, about there is probably fine. And we're just going to, I right click to change the miters. See how there's different miters up here? You can just right click, see how they change. Oh, whoops. Yeah, when I click on it, see, watching up here, see how they change? And so I want this miter for right now. We're going to go, about like that. Go over here, come down a little bit, and do the same thing. And then we'll come out over here, something like that. And something kind of like, actually, hold on, I'm going to undo for a second. That wasn't what I wanted to do. Go up like that. There we go. Go out there. I want to be about somewhere around in there. Yeah, there we go. And then somewhere around in there, and then back up to that. Okay. So now we have created basically the outline of our copper pour. Now what we need to do is we need to assign it to a net, or assign it to what is it? Is it power? Is it ground? Or what is it? So we use our name tool over here. You click on that right over here, our name tool, and we're going to click on it. And then it says change the name of this polygon. So you want this polygon and GND for ground. So now that just set it. Now we can pour the copper, but I'm not going to do that just yet. You use what's called the rat's nest tool. You click that and it will pour the copper, but right now I kind of like it to be transparent so I can kind of see what I'm doing rather than having this big blue blob on here. And and by the way, if you ever want this to, if you do pour the copper and you want it to go away, all you have to do is just make sure and save your work, and then just close it and reopen it, and it won't show the copper pour. That's the only way I have been able to do that. Now I'll know those of you that might be experts at Eagle, if there's a command that you can do to turn it on and off. I know in Mentor Graphics' pads you can type PO and it'll turn the copper pours on and off. It'll switch between the pour outline, it'll turn that on and off, whether it shows you the copper pour or shows you just the outline of it. Don't know how to do that with Eagle, but anyway, that's what we do. So now what we want to do is, like I said, we want to go ahead and route these by hand, like these capacitors that are right here. So what we're going to do is we're going to come over here to our route tool, click on that. Our width of our trace up here is going to be, let's do, we'll do 15 mils. That's probably fine. And then we want circular vias. You can do a square via. Basically, if you ever have to pop down to the bottom layer and then pop back up, or just pop down, do you want it to be a square hole, a circular hole, or a octagonal hole? And so, and we'll leave the diameter as auto, the drill 23622, that's fine. All that stuff's fine. So we do want to switch layers though, back to the top layer. And what we want to do is we want to, and if you notice when I click on this, there's so many air wires flying through here that it basically, when I clicked on it, it's going to highlight this one and basically ask me, what it's asking me is, do I want to route this one? If I don't want to route this one, I can right click, well, hold on, I got to be zoomed out. I can right click and see how it selects this one, selects the other one. If I right click again, it selects this one, and basically it'll just kind of, as I right click, travel through them and be like, well, is it this one, or is it this one, or this one, or this one, or this one? And whenever I find the one that I want, I basically, and I want to route this one actually, I just left click and then it begins the route. Now this needs to change to 15. So there's our 15. And now we can just, and another thing I like doing, I do not like 90-degree angles, and I'll show you why here in a second. Make this, turn this grid down a little more here. I'll show you why I do not like right angles. In fact, I can just show you right now. Let's bring up good old MS Paint, and I will show you. Alright, basically, I want a huge brush because I want to be able to see this. Basically, if you're running along a trace, and then you do a 90 degree, and you do, oops, hold on. You're running along, and then you do a 90 degree turn. Okay? Well, that's all great and fine, but the only problem is when during the etching process. Here, I'm gonna dump some paint so we can see what we're doing here. Okay, so now during the etching process, it's more of a circular process. In this corner, it's actually going to probably etch it kind of like that, and then kind of like that. See, kind of like this. So what just happened here, unknowns to you, is that you just got, well, it's probably not that bad. It's probably like that, because it etches, you know, around and up as it etches. During the etching process, you all of a sudden your trace just went from 15 or 16 or 20, whatever mil width your trace is, just went down to really tiny right in here. And so you basically just, if this is a high current path, let's say, you just effectively created a fuse that you didn't want to in your device. Sooner or later, that's going to get hot enough times because of so much current passing through such a thin trace that it's actually going to blow. And so that is why that when we do 90 degree angles, we do a 45 degree angle. That way when the etching process comes in, it may take just a little tiny bit out of it as it goes up, and it's not going to be this huge problem like it is here. And so that's why you definitely want to keep no 90 degree angles in your design. It's not too much for impedance. However, impedance, that is kind of an issue. Angles will always give you a little bit higher resistance, but still, one of the main reasons is due to just the etching process and things that are called like acid traps and stuff. So you don't want any acute angles. You want all obtuse angles. You don't want anything that's like this going on, because, you know, if it happens, it's gonna chew out, you know, quite a bit of your trace when it, well, not that bad, but it's gonna chew out quite a bit of your trace when it does its thing. So anyway, so no acute angles, all obtuse angles. Anything got to be greater than 90 degrees, otherwise you have etching issues, or could possibly have etching issues. So anyway, so that's that brief little piece. Now let's go ahead and route the rest of this. So we're going to do that one there. Grab this one, or actually I messed that up. That's the ground. This is the great thing about having a ground plane. You can come out here, and what we're going to do is we're going to pop under, and we're just going to pop a via right here. Which what we're going to do is we're going to click the middle, or the mouse wheel, and that pops us to the bottom. We're going to come out like one notch, left click. Oh, I had trouble with that. Okay, we'll come out here, pop a via, come out a couple notches, and we're good. Hit escape, and that just popped a via, which just connected this to ground. So there we go. We just connected that one to ground. So let's come over here and let's do the same thing with this guy. Choose a miter that makes sense. Okay. And oh goodness me, I did the wrong side here. This one's the ground. There we go. And this one is the power. Like that. So there, it's that and that. Same with these. Like for the grounds, like this one, you could take and you know, let it go ahead and auto route that in. That's probably fine. Some of these other ones, that's probably fine. So we've actually got that's probably okay. What we can do is now we can set up the auto router and let the auto router route, since those are kind of critical guys. In fact, let's look at the other decoupling caps. Why don't we? Let's pull those up. We got those two. We got 8 and 9 is what we just did, wasn't it? Oh, good grief, come on. 8 and 9, yes. But we still have some other decoupling caps that are kind of important. C2. So if we look for C2, C2 is here. C2 connects to R4. R3 and R4. So it looks like that's what it's probably going to do. Its ground is up there, which is fine, but it looks like it's going to connect to these guys. We can just go ahead and connect these guys up if we wanted to. There we go. Got those guys. We can just do the via thing if we want. Escape. Okay, there we go. So that grounds all that. Is there any other decoupling caps that are very critical? These I placed close enough that, see, they're all going to go to that IC just fine. So let's go ahead and set up an auto route feature while we're at it here. Make sure and save. So we're going to come over here to the auto router, which is next to the ret list command. And the auto router, how this thing works is I've usually, you can save your setups. You have all these different constraints and everything that you can put in. That you can put in how close you can get to different things, and see like the costs of, you know, putting in a via and also. It's pretty complicated how it actually does everything, which I haven't read a whole ton on this. I just use it here and there when I need it. But the main thing is the routing types, the preferred directions. Like for the top, it routes up and down and bottom, or side to side, or at an angle, going, you know, at an angle this way or an angle the other way. I don't know what the star is. I haven't really messed with that. And you can even choose NA, or non-applicable, so that way it does not route anything, or it doesn't try to route anything on the top or bottom layers. You know, you can choose NA for the bottom if you want to try to get everything in the top layer, and it'll do that too. The main thing is the routing grid. What's the granularity that you want to deal with? How close do you want it to try to snap everything to? Which 10 mils is probably about good. And then you also get to choose your via shape, whether it be round or octagonal. We'll choose round. Round is fine. And then you've got a couple of options. You can just hit OK and it'll try to route the entire board, or you can choose the select. And sometimes this helps when, let's say, you need to just maybe auto route a couple, 3 things here and there, or specific things you want auto routed. You can choose select. Like for example, let's select this one. I want that one, and let's say this one, and that one, and that one, and that one. Okay, so you just click on each error wire to select them, and then you hit this go button, basically the little stoplight here. There's stop, and then stop is just cancel. It'll cancel it, and then go. If you click it, it does it. Now see, it also shows the copper pour. It does the rat's nest deal and shows the copper pour. So there's our copper pour. It auto routes those, but it doesn't auto route anything else. Now we're going to go ahead and click on our router, and we're going to go ahead and just say go, and we'll see if she can auto route everything. What it'll do is it does this kind of jumping around stuff, which is it optimizing. It optimizes what it's doing. If you look over here, we've got optimized. We've got 100% finish, which means it was able to route 100% of the board. So it did it all. But you've got things like, if you look here, you got stuff like this. So you have to use your miter tool, and we'll do, I don't know, a 15 mil miter. And see, you gotta catch that. So you gotta inspect. So here's another one. You gotta inspect your stuff, because it doesn't care about board manufacturability, and it will put the deals. And see, like this right here, I don't like this at all. So what I'm going to do is I'm going to use what's called the rip up tool, and I'm going to rip up that trace right there. And what I'm going to do, whoops, is that one's fine. But then I'm going to come to route. I'm going to route it, except I'm going to come, oops. See, in these traces, I can't remember what width we had set. The width is 8, so it'll do an 8 mil trace, which is fine, I suppose. We can do route. Come here, except we want the width to be 8. So we're going to come up and we're going to just move it on over into there, like that instead. Other places, yep, I see more places. So you basically got to come around through and touch up everything. You know, anything that's, the auto router is great, but at the same time it's not perfect. So you got to kind of touch up some stuff, you know, and just kind of review your design and see what it's doing. Then once you get done touching it up, which I've already routed this board and saved it, it's just kind of for demonstrational purposes. Once you do it, then you run the DRC checker, which is over here. And the DRC checker is actually pretty slick. What it does is it's the design rule checker. And what it does, it checks the different layer clearances, pin clearances, the distance between traces and vias. It does all. This is where you set up all of your design rules of how close you can get stuff. Now, design rules will change via board house to board house. So you want to check, but the cool thing is I've noticed a few board houses actually give you DRC files made just for Eagle CAD, which is very cool. So you come down here to load, and like for the Sparkfun one, double click on that, and you just click check. Checks the whole design. Now we have a few clearance issues. Let's look here. Looks like that's an issue. So you just, what you do is, like, we need to probably rip that up, and we will just reroute it and make it a little bit different. Maybe bring it up here. There we go. And then where's our other clearance issue? So it shows you. See, same thing with this one. So we'll just rip that up, reroute it real quick, so like we know what we're doing. Okay, and then there's a width problem somewhere. There's the width problem. Oh yeah, because we have in our design rules that we need 8 mil widths. So the information tool, and we'll change that. We'll make it 8. And that way it'll be happy. So I make that 8, and then see, now we run the DRC checker again. And if you look down here, at the bottom left, it says no errors. So everything is perfect. It means this board is to the specs of Batch PCB's board house's specs that they gave. And I'll probably, in the description of this, I'll give you the link and everything that takes you to that place where you can download those design rules. So so you'll have them. Sunstone Circuits, I know, has them as well. You may have probably seen that in there when I chose load. I've got Sunstones in there because I use that board house sometimes. Yeah, that's what this is, Sunstone Circuits. And some other stuff. There's some other guys, and they'll print you, they'll build them for you, so that's kind of nice. So basically that's the board. Next video we'll do Gerbers, and showing you how to, for part 3 we'll show you how to make actual Gerber files of this, which Gerber files are the basically machine coded files that you'll need to create to give to a board house so that they can manufacture your board. They don't have, some board houses may not have Eagle CAD or whatever CAD software you're using, but Gerber files are a universal file that you can give to any board house, and it tells them exactly how to build the boards. It's actually, there's a file for every layer. So there's a silkscreen file, solder mask file, there's the top copper, bottom copper, there's all the drill holes are in a file, all that stuff. So we'll do that in part 3, so stay tuned for that. Thank you very much.